Hi everybody and welcome. Today we're going to be talking about proofs with parallelograms. So actually there's no new information today. We're going to be using all of the same things that we used from last video. The only difference is that we're going to be applying those same things to proofs. So actually going to be doing a little bit of typing today because a little bit of notes, a little bit of, a little bit more words. So our first proof. So for this, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. In normal person speak, this is just saying if you have a four-sided shape and opposite sides are equal, then it's a parallelogram. So that's kind of the language that we can use for this. So I'll say that's our proof, and then this is just like our in plain words. So that's the first one, and you can use that for your proofs, and kind of that's the idea, is that if you are able to prove that the opposite sides are equal, then you're able to prove that it's a parallelogram. The second type of proof that we're going to have is as follows. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. In more like plain words, what this is saying is that if opposite angles are the same, then it's a parallelogram. So if you can prove that angles across from each other are equal to each other, then you also have proved that it's a parallelogram. It proves both of those things. All right, our third proof if the diagonal of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. This one's a little bit more tricky to put into plain words, but it's basically saying if the diagonals of a quadrilateral split into equal parts where they cross, then it's a parallelogram. Our last proof here, so it's our fourth and final proof, is if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. And in plain words, what this is saying is that if you can prove if opposite sides are parallel, then it's a parallelogram. All right, so the second part of these notes, we're going to transition from words into some drawings of each of these four proofs. So I'll kind of be scrolling back and forth between them. And then from there, we're going to move on to doing one or two examples. So for our first proof, an image of it is you have a parallelogram like this, or a quadrilateral, I should say. It has four sides. And if you can prove that these sides are equal, so like this and this are equal, and if you can prove that this and this are equal, then we can say that it is for sure a parallelogram. For our second proof, This one is about our angles. If opposite angles, so angles that are across from each other, so this one and this one are equal, I'm going to highlight those. So that angle there and that angle there, as well as, again, all opposite angles are equal, then again, we can say that it's a parallelogram. So again, we're saying that those measures are exactly equal to each other. If one of them is 30, then the other one also has to be 30. For our third proof, this one I think is the most difficult one out of the four. Bisectors are lines that go from one corner to another. What this is saying is that this red section has to equal the yellow section. So the red highlight equals the yellow highlight. So this right here is equal to this right here. Additionally, let's say we have a green highlight. This green highlight has to equal the blue highlight. If that is true, so if we have split these into equal pieces, then that means it is a parallelogram. So a little bit tricky, but we're basically saying red equals yellow and green equals blue. For our fourth proof, the only thing that we need to prove is a single set of parallel lines. So if we can say that this and this are parallel, so if they extend forever, forever, forever without crossing, then we know for sure that it is a parallelogram. So there are some detailed notes on those four proofs, and we're going to finish the video today with a few examples. And we'll do two. So the first example if you have a quadrilateral that looks like this, and let's say we have some angle measures filled in for us. So in this case, this one might be 120, and this one might be 60. And they're going to ask you, prove whether it's a quadrilateral. A parallelogram, sorry. Well, first we need to actually decide, is it or is it not a parallelogram? So let's scroll back to our proofs. We have some angles. And it looks like that's going to be our second proof. So we need to prove that angles across from each other are equal. So we're looking to see, does this equal 60? Does this here equal 120 degrees? There's some more information they gave us too. They said that this is 14 inches and this is also 14 inches. So based off of this information here and based off of what they gave us, we're trying to set this up in a way to prove whether or not this is a parallelogram. And we need to use one of those four properties that we saw from above. A second type of question that they might give you is the following. They give you a parallelogram, and they might ask you to solve. So it might be something like 2x and then, 4x minus 24. And it could also be something like 3y and then 6y minus 36. And in this case, you have to solve. They tell you it is a parallelogram, so you're going to have to set opposite sides equal to each other. So what that's going to look like is this side is going to have to equal this side. So 2x equals 4x minus 24. Or you could additionally do opposite side equals opposite side. So you could also do something like 3y equals 6y minus 36. So again, in this case, subtract 6 from both sides, subtract 6 from both sides, we get minus 3y equals minus 36. Divide both sides by minus 3, and we get y equals positive 12. In this case, subtract 4 from both sides, get negative 2x equals negative 24, divide both of these sides by minus 2, divide both by minus 2, and we'll get x equals positive 12. So, and actually both of these just happen to work out to be 12, but that is the idea when we're working through questions like that. All right, so for our final example here, we're going to take a final note of how to go through one of these proofs. So one of the things for parallelograms that we know from our properties yesterday is that consecutive angles are supplementary. So here, what this one is telling us is that 120 and 60, they're next to each other, so they're consecutive, so they have to equal 180. Well, is that true in this case? It looks like 180 does, in fact, equal 180. So that is one way that we are able to go through and prove this. An additional way that we can go through and prove this, again, we want to focus on what we had for our proofs today. So I don't think any of these 4 proofs tell us about consecutive angles. Let's look back at our notes. It says opposite angles for the second one, nothing about consecutive. Let's look to the first one. If both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So in this case, we can see we have opposite sides that are congruent. So a second way that we can prove this, and both of these are options, we can say opposite sides are congruent. So that would be another way to prove this, because 14 equals 14. We have to be careful, because with this opposite sides, it means both. We also have to know what is this and what is this. So a final way that we can go through and prove this, so maybe a third option here, there's quite a few different ways we can do this, is if we extend these lines, it's actually going to bring us back to what we were working on earlier this year. So if our interior angles, and this is going way back, so our third way here, so consecutive interior angles are supplementary, then it proves that lines are parallel. So that means that because these two add up to 180 degrees, that this is parallel to this. Now, of the 3 ways we did this, way number 1 is good, way number 3 is good, way number 2 is tempting, but we still haven't proved that these two sides equal each other. So either one of those options, number 1 or number 3, would be acceptable ways to prove that this is a parallelogram. 2 is close, it's halfway there, but we don't have all of the sides, and we actually, in fact, need all of the sides to be able to do this here. So hopefully this video helps. Your big takeaway from the video, though, should be really focusing and doubling down on the 4 proofs from the start. So if you have good notes on 1, 2, 3, and 4, as well as good drawings on 1, 2, 3, and 4, you'll be in good shape. A reminder, go back, rewatch, pause, rewind, do whatever you need to do to get those notes down for 1, 2, 3, and 4.